Theoretical versus experimental probability. The first type of probability that we are going to talk about today is theoretical. Theoretical is, this is what should happen. In theory, using all of the math, this is what is supposed to happen. And we use the formula, favorable outcomes and we compare it with our total outcomes. Going back to the example, what is the theoretical probability of rolling a dice and getting a 2? Well, on a dice, there are 6 total outcomes. So the 6 would be in the denominator. There is only 1 2 on a dice, or a die, and therefore it is 1 out of 6. If we turn that into a decimal point, we get 0.16 with the 6 repeated, and therefore we can turn it into a decimal, or into a percent, and get 16.7%. The second type of probability that we're going to talk about is experimental. If you are actually rolling a dice 10 times to see what the probability would be, that's experimental. That's not using the math, that's actually physically doing it. So, the number of times an experiment is performed, the closer the experimental probability will be to the theoretical probability. So if we were to roll a dice 10 times, our experimental probability might not be that close to the theoretical probability. It will probably be closer when we do roll a dice 100 times, since the more often you do it, the closer you will get. The formula for this will be the number of times you perform the experiment and the desired outcome occurs, and we're going to compare that with the number of times that you perform the experiment. The number of times you do something is called trials. The first thing that you need to do with experimental probability is perform the experiment. Then you want to perform the experiment 3 times. So repeat with 3 trials. And for each time that you do this, you need to record the data. The graph shows the results of an experiment in which a spinner was with 3 equal sections, that's very important, they need to be equal, is spun 60 times. And here are the results over to the left. Green happened 21 times, blue occurred 15 times, red occurred 24 times. So we want to find the experimental probability. The total times that the spinner was spun was 60, so that's how many trials there were, and there were 24 that landed on red. If we reduce that, you get 2/5. Change it into a decimal is 0.4, and then changing it into a percent would be 40%. Now we want to compare the experimental probability with what we found with this last one in example 1. Theoretically, since the 3 spinners are equal, there is a 1 out of 3 chance of landing on red. We got 2/5 with the experiment. Comparing the percents makes it a little easier. 1/3 is 0.3 repeated, so that would be 33%. 2/5 is 40% that we found previously. They are very close together. Therefore, we can say that the experimental probability is close to the theoretical probability. 2 coins are tossed 10 times. Both coins land on heads 6 times. So that means the experimental probability would be 6 times that the coin landed on heads and the coin was tossed 10 times. That reduces to 3/5, which would be 60%. Now, if we look at the theoretical probability, we have to look at each coin individually. So 1/2 for heads on the first coin, 1/2 for heads on the second coin, which would give us a theoretical probability of 1/4, which is 25%. These two percentages aren't close together, so a possible explanation is that there were not enough trials completed during the experimental probability phase.